Hey Arshal, thanks for joining this demo interview with me. I really appreciate you joining in such a short span of time. So what we'll do is I'll quickly introduce myself and then I will hand it over to you. You can do a quick round of introduction. Then maybe we can dive deep into the interview. Okay, so a quick intro about myself. I head the technology at one of the service-based companies back in India. I have about 13 plus years experience in the IT industry across multiple domains and multiple geographies. For the initial 6, 7 odd years, I have been a full stack developer, and over the past 6, 7 years, I have moved myself into the infrastructure space. So right now, my role is handling both the full stack development as well as the infrastructure. So yeah, I'll hand it over to you. Maybe a quick round of intro, and you can tell me about what kind of projects you have done, what kind of customers you have handled. Yeah, so over to you, Harshal.
Thank you so much, Ajit. So myself, Harshal Kunke, and I have been working since almost last 5 years. I have deal with variety of customers across various domains throughout the world, starting from America region to APAC region. And I have worked with customers who deal with healthcare, blockchain, AI startups, and then the big corporations who are dealing with the uh, very large scale enterprises basically. So my primary skill set is cloud and DevOps. Also, I'm senior cloud DevOps engineer working with one of the largest uh, service-based company here in India. Uh, it's actually service/product, but yeah. Uh, my primary skill set includes AWS, GCP, Kubernetes, Terraform, and in general DevOps and GitOps practices. I have also worked with the native DevOps tools like GitLab, ArgoCD, and then various pipeline tools that we use in our day-to-day lives. Um, yep, that's all. Ajit.
Okay. So what kind of AWS tools or AWS services you have worked with? Can you brief me about it?
Well, the list is very long, to be honest.
Okay, yeah.
Start naming few. There are services like AWS VPCs, EC2 networking, and in general security. This is something that has to go on all of the project, irrespective of what sort of architectures you are building, right? But then there are some niche category of services like uh, control tower. I mean, not every project or every organization needs a control tower. It depends on how large is your architecture, how much scalable and dependent your cloud architecture is, and how critical the application is, right? Then there are a variety of logging and monitoring services within AWS, like CloudWatch, CloudTrails, and then the multiple databases like IDS, Aurora, DynamoDB, and a lot more of this variety of compute services as well. I mean, the list keeps on going. So yeah.
Okay. So considering your overall experience with EC2 and other tools or services you mentioned, right? How would you architect a highly available as well as a fault tolerant application on AWS? So maybe what kind of services will you use? What kind of architecture it will have? So maybe can you brief me through that journey?
100%. But Ajit, I'd like to ask a question. Do you have any specific conditions or requirements in mind while we design this architecture?
Okay. Consider maybe an e-commerce application. It is accessible from the entire world, from all over the world, and
Okay.
it has to have a low latency. Okay, so for example, someone from Mumbai is accessing that application. So it is not necessary that the servers that we are getting all the requests or fetching all the database or the data is necessarily from the US region or the Singapore region. So the latency has to be very low. The speed of the application has to be really fast. And of course, as you mentioned earlier, security has to be of the utmost importance. So considering all these scenarios, maybe and you can just brief.
Okay. Awesome. So that's an awesome use case to discuss about. So first of all, we'll go step by step. Like basically what we need is, in terms of applications like this, primary thing is the main priority for us is to have it very low latency and fast delivery to all the end users all across the world. Second
Right.
priority for us is the security of an overall application, right? Considering those facts, I'll skip the basic part where we deal with VPC and subnets. We'll be creating basically kind of a three-tier architecture. We'll have the databases, we'll have the compute in one subnet, and then one will be a public subnet for us. So I won't go into the basics of it, but let's go into the technical parts of some of the interesting stuff about this particular use case, right?
Right.
So primarily, we have to have the CDN in place, and we have to have the database, which is kind of in replicating across multiple regions or kind of in a global database. So what comes to my mind is DynamoDB's global tables, right? This can give you a low latency when you're fetching across multiple regions. Your compute, secondarily, will depends if you are going for monolithic or microservices application. So considering the fact that this is an e-commerce and there will be a lot more sub application inside it, like maybe fetch a cart, show the items, give the description, maybe a review system, maybe a feedback loop, maybe a customer service, right? So all of these applications can be divided into a variety of services and can be deployed easily on the Kubernetes. So we can use EKS basically. And because we need this to be fetched from multiple regions, we can leverage the power of Kubernetes, especially the EKS, where we deploy the node groups across multiple regions. Maybe, for example, we have in US one instance of an application and another in Mumbai, right? So we can deploy the application across multiple regions like that. And on top of it, we have the CDN layer, which kind of caches all the data and reduces our latency drastically. Again, now that we have also prioritizing the security, any applications like this e-commerce application always doesn't do everything on their own, right? They will be doing or utilizing some third-party APIs. They'll be utilizing some payment gateways, and they will be interacting with these services via the APIs. So we need proper security measures to store these API keys and the access mechanism for these APIs for payment gateway and everything like. So we will be using AWS Secret Manager, and for not very sensitive data like the end URL of the payment gateway that or the API gateway, right? So we can use a parameter store to store this kind of data and utilize that. That can be easily seamlessly integrated with the native AWS services like in EKS because we are using Kubernetes. We then can use AWS S3, which is a really good service, to log and create backups of all of our databases and the applications itself. This will most probably going to be um, repetitive application, and because I need because it's an e-commerce, I also need to consider the fact that it might get traffic spikes during certain time of the day or certain time of the month or maybe in a festive season, right? So we also have to consider the fact that it has to be highly available and highly scalable as well. And because I am using Kubernetes here, I can easily use HPA, vertical, horizontal pod autoscalers, vertical pod autoscalers, and then we can use the cluster autoscaler, which is AWS managed totally. Autoscaling basically will be a crucial part here. Then we need to log and monitor everything. So for that, we simply go with the CloudWatch and CloudTrail to trace all the logging and everything happening. If this application is split into multiple AWS accounts, which is totally a different scenario altogether, because there might be a case, right? You might not want the same version of website to be shown to a US customer and an Indian customer, right? In that case, you might just want to split your application across two accounts, or maybe because it's already separated by region, but you might want to separate it by accounts as well. In that case, you need to have that inter-account connectivity. You need to enable the VPC flow logs to track all the incoming and outgoing traffic. And by utilizing all these services, you can get low latency with the CDN. You can get the backups and everything with the S3. Then you can strategize and build processes for your restoration, and in case of failure, fault tolerance. These are most probably the processes that you will be establishing, right? Apart from that, for the security, we'll be using the CloudTrail primarily to trace all the actions which is happening in the cloud, and then VPC flow logs for the incoming outgoing traffic, and then we'll be following the basically IAM, least access privilege. So all the basic AWS stuff that will be counted. Also the NAT gateways and security groups, I'm considering that we are not going deep into it because they already considered that it's being set up as per the best practices.
Okay, okay. Yeah, so a couple of follow-up questions I have on this. Okay, so you mentioned about the CDN, right? So you would be using, I assume, CloudFront for CDN and not any third-party tool, right? So that is more related to your static caching, right? So if I want to cache certain database components, like, okay, so for example, in your website, there are few things that are not frequently updated. Maybe like they are updated once in a month or twice in a month. So in that scenario, we need to also cache the database, right? So what kind of tools or what kind of services will you use for that?
So to answer this specific question, it's highly dependent on what sort of data we are dealing with here. So if it's just if we are just dealing with the NoSQL, then I'll highly recommend using the DynamoDB's global table because that kind of caches everything across the regions, and it is completely AWS managed, so you don't have the manager overhead, or you don't need to worry about it basically. So it makes our life easier. But in case there is no NoSQL database that we are using, it's maybe a simple MySQL database or the PostgreSQL database. In that case, we can go for RDS, and then we can create a replicas across the region, which will kind of sync your data in between. And for the use cases where the something which will be being accessed after a month or so, replicas will do the job because it's not the real time, but it's almost near real time. So that's not a major problem for this particular use case.
Okay, so in case of MySQL, maybe you will use something called as ElastiCache to maybe fast track your speed of the website.
Right.
Okay, okay.
So Elastic is in front of the database, and but in queries where the data is not being accessed for a month or more than that, uh, ElastiCache, we will sort of add a filtration process where we don't want to store very old data, like a month-old data into ElastiCache, because that will add up a cost real fast, right? So in that case, replicas will be a good option. But again, it depends highly on what sort of data we are dealing with and how critical the response time of that data is, right? So if that data is being accessed after a month and user can wait for 1 or 2 seconds, then I don't think we need to go for an expensive solution. So that's just my opinion. But yeah,
okay.
it's debatable.
Okay, fine, fine. Yeah, so initially you mentioned that you will work on EKS, right? So I was curious to understand from your end, why you choose EKS over maybe slightly more cloud native tool like ECS. So what benefits you find that EKS have against ECS, or maybe why EKS or ECS cannot handle this kind of a load? So what do you think?
Okay, so I'll just simply talk about the primary difference between EKS and ECS first. So ECS is basically, in the layman language, it's basically a Lambda function, but for Kubernetes, right? Because you can simply spin up any containers on a Kubernetes, which is fully managed by AWS. You don't need to do anything. You just specify the task definition, the required configuration for your particular service or job, and ECS handles it all behind the scenes, which is very easy if you're dealing with the small scale application, maybe some sort of batch jobs, maybe something which just quickly processes your request and gives back a response. In that case, ECS is the perfect solution. We don't need to go for EKS. But EKS gives you more control and more configurational power over how your Kubernetes is being deployed, and you can manage your scaling more uh, comfortably based on your requirements. In our case, particularly, we had a requirement that the application has to be accessed to across the world and with very low latency. In that case, if I spin up ECS, that will going to get very complicated. I need to spin up the same resources again and again in multiple regions, which is very hard to manage. And over time, there can be a lot of drifts into the system. But with help of EKS, I can simply do all the things with Kubernetes. All of my stuff is being managed by maybe Helm and being deployed through a pipeline with the help of ArgoCD, kind of like a GitOps approach. Uh, So my developer and my management team no need to deal with all sort of this configuration, because my Kubernetes will behind the scene will manage everything for me, because that's how it will be configured. But that power you can only get with EKS and not ECS. So this is the primary difference. And the only reason why I choose EKS here is that we need that control to deploy over across the regions. For example, I just took two, but there might be 10 regions where we want to deploy, right? So EKS make it very easy. But another benefit, now that we're talking about EKS, another benefit that EKS provides, in case your application is already on premise and it's been running on premise, or maybe some critical part where you maybe reset password, or maybe you process something very highly critical financial related data, and that has to be on your on-prem and cannot be moved to cloud. In that case, the EKS can also manage those applications on Kubernetes as well. So you get a centralized control over all of your compute applications, and then you can tweak it based on your requirements.
Okay. Okay. So in the current infrastructure setup that you spoke about, okay. So how will you ensure that we are covered in terms of disaster? Okay. So if something goes wrong to your primary database, or if something goes wrong to your maybe EKS cluster, so how will you ensure that the lights are always on and no users are facing any issues whatsoever?
Okay, so that's a wonderful situation, but there are two primary things that we need to consider in this case, Ajit. First is how much cost is manageable or bearable by the customer for this particular setup, because having the disaster recovery setup will gonna occur a lot of cost. Second primary question is how critical is your applications? If the applications are super critical, you don't want to miss the application. You don't want to miss any data related to that particular application. And then in that case, the cost is not a major problem, right? So it's kind of an inversely proportional to each other. So there are a couple of scenarios. Let's talk about those. So in scenario where you're okay with losing some data, and you're okay with the application taking some time to spin up and then take the request, in that case, you can simply spin up the completely new application when the primary system goes down, and that will have the least cost compared to rest of the application. But it will, but you'll end up losing some data, and you'll end up uh, losing some time to spin up a new application. Second scenario is your application is moderately critical and you can bear some cost. In that case, you can start a you can use the AWS's global services. In our case, we are kind of an already using those, like an AWS DynamoDB global tables, maybe the RDS with multiple replicas, and Kubernetes is spread across multiple regions. So it's highly unlikely that all of the regions is going down. But in case it does happen, Kubernetes will automatically spin up the new nodes, because the reason we have enabled the auto scaling. But that's still going to take some time compared to considering the fact that your application is moderately critical, you can bear that, but it does not cost you so much. But for the cases where application is super critical and you cannot even lose a second of downtime, and you cannot even afford to lose a few seconds of data, in that case, the only option is you spin up a completely warm replica of entire infrastructure across another region that just stands there, and your load balancer or your Route 53, you based on that, you check the health. As soon as your application goes down, your all the request routes to the different region. So you don't lose any data. And to you need to also consider the fact that how the data replication will happen for the dynamic data, but then the compute doesn't go down and your application is always up and running. So it's totally depends on what is the priority of business. Is it the time or is it the money? So based on that, we have to make the decision for the disaster recovery setup.
Okay, but you already know the scenario, right? We are an e-commerce application and we cannot afford any sort of downtime. At the same time, we are also cost sensitive. Okay, so whatever decisions we make, it has to be well informed and well thought of. Okay, so this is what the scenario is. So maybe you can explain in detail this kind of a scenario.
Okay, I'll give a very simple example with this. So regarding data replication, my tables will do the job, my replicas will do the job, and I also have maybe an hourly backup or a daily backup for just to be safe on the S3. and S3 already replicates it across multiple regions to store your data securely. Let's talk about the compute specifically. I understand that our application is critical, but we also need to consider the fact that the e-commerce application is divided across multiple applications. So the application, let's say, which deals with creating new user and creating an order is very critical, because creating order gives us a business. But the application where we do a customer feedback, maybe reviews, the application where customer raises complaint, that is not as critical as the previous one. So in that case, the secondary application can be set up with the cold disaster recovery setup, which we talked about, and the critical ones like creating user, creating orders, making a payments. This sort of application can be set into warm replicas of the instance. So dividing these two will ensure that you incur as much as less cost, but you also have the as high possible uptime for your application.
Okay. Okay. So yeah. So in our previous conversation, so you mentioned about CI/CD, right? So I was also curious to understand. So if you want to develop CI/CD pipelines, okay, or entire DevOps architecture for this kind of a e-commerce application. So what would be your steps or measures, or what kind of tools you'll use, what kind of third-party integrations you'll use? So I wanted to understand, or maybe walk me through the entire CI/CD journey.
Okay. So again, just like every other assumptions that we make while making any sort of this architecture level designs, we have to consider what are our priorities. There are a lot of CI/CD tools available, and all of them are better than each other, right? In every term, but we have to pick the one which is more suitable for us. So we have to ask the customer the questions regarding what is your priority. So if you as a customer, Ajit, are storing your entire code base on GitHub, in that case, using GitHub actions is the perfect solution for you. If you are storing your all the code base on the GitLab Enterprise or GitLab Normal, that case GitLab CI/CD is the way to go. But if you don't have anything as such, and you're open to exploring the AWS native services, and you're storing your code on AWS code commit, in that case we can simply go ahead and use the AWS native CI/CD tools. So primarily I have been working with these three: GitHub Actions, GitLab CI/CD, and AWS Code Pipeline. Each one has their unique advantages over the other. Like AWS native tools integrate seamlessly with each and every AWS service that we are considering to use in our architecture. And it provides a great control because all of your system and everything is under one roof of AWS, right? But again, the problem with that is you are again dependent on AWS. Maybe tomorrow, if AWS goes down entirely, your code is also gone, right? And that's very highly unlikely to happen, but we have to consider the fact because it's a business critical thing. So then you decide to go with the GitLab. In that case, again, second question is how are you designing your architecture? In our case, we are using Kubernetes, and we are considering the fact that we have to spin up it across regions. We have to have a disaster recovery plan. In that case, we will be 100% using the Helm, the ArgoCD with the Helm, right? Basically the GitOps approach to do the deployments. In that case, let's consider that my code is stored on GitLab, and I am using the GitLab CI/CD. So let's talk about how we will need a pipeline setup. Now, once the tool is decided, another question arises is how you have structured your code. So there are basically two things: your infrastructure code, which is IAC, uh, will you'll be using CloudFormation or you'll be using the Terraform. So I'll again make an assumption that we are using Terraform here. Uh, so again, is it a separate repo, or is it in the same, you're using like a mono repo structure for your application code and Terraform code? Maybe in e-commerce website, there are a variety of applications. So are you storing all the application in one single repo, or each application has its own repo? So we have to consider this part. So to make things easier, I'll consider that everything is under one repo, because it's kind of a startup and everything is under one repo. All of the applications are separated by folders. And then there is one more parent folder which kind of shows my Terraform code. So I'm considering this basic repository structure. In that case, because we are also using GitLab and the ArgoCD, we have to go with the GitOps approach. So we will have variety of pipeline stages. In GitLab, we call them the pipeline CI pipeline jobs. First job will basically checks if your code has any errors, your code has any typos, or is syntactically correct. Kind of an linting checks, basically. It's properly formatted. There are no extra indentations or wrong spaces you have added, right? So that kind of cleans the code and checks for any of this sort of mistakes. Second stage, maybe you are doing some sort of testing, maybe unit testing on your code. If it's a Terraform, then you are doing some tests related to if the code is valid, basically the validate, Terraform validate, if code is correct, it can be run or not, right? Then third stage, now we kind of need to separate the code and the infrastructure. So let's talk about code first. So because we are using microservices, all of our applications get containerized, right? So there will be a job which basically takes the application code, builds a container out of it, and then pushes that container, the Docker image to the ECR repo. I'm considering that you are storing all the images in ECR. That image gets pushed into ECR repo. And then in another job, because it's a GitOps setup that we are using, and the changes are being pushed to Git repo. So our GitOps get triggered, and as soon as the new image is there, the code has been pushed, the ArgoCD gets in effect and does the deployment of your container. So basically it goes into a Kubernetes, logs into Kubernetes, tells Kubernetes to update this particular image for this particular deployment, and Kubernetes does its magic and your code is deployed seamlessly. In case things go wrong, you always have an option related to rollbacks and the specific jobs for the rollbacks. But there will be cases where you don't want everything to happen automatically. You might want some sort of manual control. In that case, you can always have a manual approval process in the pipeline for critical things. For example, if you are deploying a Terraform, you are deploying an infrastructure. In that case, you did Terraform init, you did Terraform plan, you are going to do a Terraform apply, but you don't want to do that because you want to have some time, have somebody to review your plan first. In that case, your apply goes into a manual state. Somebody approves your MR or PR, and then somebody checks your Terraform plan. If it's correct, it's expected, and then manually hit the plan, then Terraform apply gets effected. Though we are storing GitLab, we also need to consider the fact that the Terraform's state file is stored into a remote location, S3 with DynamoDB setup, basically. Now, a very interesting part about this whole architecture design and whole setup, because it is outside AWS, it's a GitLab server. Maybe you're using GitLab SaaS or you are using the GitLab instance. In both the situations, you need some sort of way to authenticate with AWS to do the operations. And second thing is you need to store this authentication related to authentication related keys into GitLab, and that should be very securely, right? So in such scenario, AWS gives you RBACs, which is kind of an IAM roles where you build a trust identity relationship with GitLab, and particular GitLab, your SaaS URL will only be able to assume a particular role and then get an access to AWS resources and do its job. In terms of storing your secrets for the GitLab and every other cloud service or pipeline service basically provides you an option for storing your secrets. GitLab also has the secrets option where you can store the secrets and manage who can access the secrets. So only a particular set of people will have the access, and those secrets will never be printed into the logs or never be shown to anybody else. People who will be using a pipeline will have no idea what the secrets are. So that's how you keep your credentials secured, even though the pipeline is sitting outside the GitLab.
Okay. So you mentioned GitOps and ArgoCD, right? Okay.
Yeah.
So I wanted to understand what is the exact need that you need to have maybe a GitOps or maybe ArgoCD kind of a setup. Can't we do a traditional way like use Helm, use Kubernetes YAML files? So what kind of benefits your GitOps gives you?
it's kind of a same benefit that you get while using Terraform instead of AWS's SDK, which is basically SDK and Terraform will give you the same benefits, will enable you to do same things. But with AWS SDK, you have to write down the whole code, and with each code, you have to manually manage all the resources and all the iterations of these resources, right? But Terraform will give you an opportunity to create modules, to create a reusable code, and Terraform will simplify a lot of things for you. Kind of in the same thing, GitOps will do. Basically, the ArgoCD with the help of Helm charts. Helm is basically a Terraform for Kubernetes. How the Terraform is for AWS, Helm is for Kubernetes, right? It's a IAC for Kubernetes. So Helm charts will have all the configuration that you need for your application and all the because configuration for all of the, let's say it's a deployments, right? The configuration is going to stay same, but the values of this configuration is going to change based upon your environments. Let's say you're using Dev, UAT, and then prod. For these, the values will change, and those values will be passed to a Helm chart. So you don't repeat your code for 3 environments. You might want to spin up entirely new thing into totally new region. In that case, you don't need to deal with a lot of things. You just simply update a region value, and Terraform, with the help of the ArgoCD and Helm, can spin up everything for you without a lot of efforts and complications on your side. So in our case, because we are dealing with a lot of regions and we are dealing with disaster recovery, or there, let's say there is a security threat which has happened and somebody get an access to our AWS and started deleting resources randomly. In that case, I need to spin up everything from scratch, right? While we build architectures, we have to consider every single situations, right? So if something like this happens, I want my whole infra to come up as soon as possible, and that will happen only when I'm using with Terraform, with Helm, and ArgoCD, because the deployments on Kubernetes will be managed totally by that.
Okay.
Yeah.
Okay, fair enough. Yeah, so we spoke about CI/CD, we spoke about scale. Okay, so moving on to observability. Okay, let's consider the same set of infrastructure that we are talking about since last half an hour. So let's try to understand how would you observe. Okay, I wanted to understand in terms of both front end, back end, as well as databases. How would you observe the entire infrastructure?
Okay. So AWS kind of gives you this option to automatically set up all mostly with all of most of the services automatically set up the logging and monitoring with the help of CloudWatch. So your CloudWatch can get logs of most of the services possible. And in AWS, once you get into a console of particular service, you can always find the logs tab there, which automatically logs. But that logs might not be sufficient, or you might need an in-depth logs, right? There might be a situation where you want to have a dedicated logging agent installed on your system to deeply trace every single thing which has been happening. So for example, again, let's take a financial application which we have, which is basically making payments, making refunds. For that, I want to log every single thing which is happening, because that will be my compliance requirement. In that case, I will want to have a logging agent along with an application. So I can use in Kubernetes, I can use a sidecar container to install a logging agent, which basically pulls all the logs and throws that into maybe my Grafana, right? Uh, and based on Grafana, I can do the monitoring for these applications. Also, the AWS CloudWatch has a configuration where you can get an in-depth log, more detailed logs, which is kind of an adds up the cost, but yeah, it's totally worth it if that's a requirement. And CloudWatch will give you the dashboard where you can modify or create your own dashboard based on the metrics. So it's not a one solution. It's kind of a mix of maybe third-party services like a Grafana and the CloudWatch.
Okay, so how would you ensure that you are able to trace all the requests? Okay, so where I'm coming from is you have multiple pods on your Kubernetes cluster, right? The EKS cluster. So how would you observe or maybe trace all the requests flowing from your pods? Okay, so which kind of tool you'll use for that?
Um, Pod logging kind of gets me high-level data of that, but if you want an in-depth tool, Ajit, that is something I think I need to look up before I make a comment on that.
Okay.
Something I need to look at.
Okay. Okay. Yeah, maybe we can have a conversation around that maybe later. Okay, couple of more questions, Harshal, on the very scenario that we are talking about. So, have you implemented or maybe have you considered Ingress in this particular infrastructure?
Yeah, I mean, just like the VPC and security groups,
Hmm.
uh, when we are setting up the applications like an e-commerce website, we are already considering that there will be few of the APIs from the application that will be managed through API gateway, and the rest of the applications, basically the front end, will be have basically Ingress in front of it, right? In Kubernetes, yes, we have considered the fact that there should be an ingress, and that can be the application load balancer. And if you have a very niche needs, very specific need related to network, and because we are dealing with latency, maybe we can go for the network load balancer as well for ingress. So you'll
Okay,
have
have
an
you?
option
Okay,
to.
so when you talk about Ingress, have you worked on any specific Ingress controller? Like maybe if you are working on AWS, so there is ALB Ingress controller.
Yeah.
So have you worked on that?
Yes, I did that.
Okay, okay. And have you, or maybe have you factored service discovery? So as you mentioned, right, the infrastructure is quite huge. Okay, there would be a number of microservices. So do you see any need or any requirement of having a service discovery tool, maybe something like an Istio?
Uh, yeah, I mean, we cannot neglect the fact that it might be required, but again, it totally depends on how interconnected are your services. In our case, our all of our applications talk to each other, and it again comes drills down to the fact that how the code is designed to talk to other services, right? So if it just simply throws the request, then you need to have the so like service discovery, right? So Istio is one option. Then you can use the service mesh to achieve the same results. But if your code has, I mean, if it's a simple application and it's a small scale application, in that case, you straight away just call the deployments or ingress, and that can also do the job. So again, it depends on how much depth your application has and how much it is required, because we have a strict measure along with the latency and uh, the highly availability. We also have the cost as one of the measure, right?
Correct, right, right. Okay, all right. So while we were discussing the CI/CD, right? So there were a couple of points I have written it down. So I think the code commit is no longer accessible on AWS, if I'm not wrong. And the other thing is in Terraform, you also don't need DynamoDB to store your state and to lock your states. So these are the updates that I think we have. Apart from that, I think the rest of the things were pretty straightforward. Okay, Arshal. So moving on, have you faced any challenges of late in your DevOps or cloud journey so far? Or maybe anything that you are really proud of, you would like to explain?
Yeah. So that's a wonderful question, Ajit, because what sort of job will have as a DevOps engineer if we are not facing challenges every alternate day, right? There are always new challenges, new issues that we are solving, new problems that we are solving in our day-to-day jobs, right? But one of the primary story that I'm really proud of and was very challenging was when once I had to upgrade around 8 Kubernetes cluster, which had almost 10 nodes each and 50 or 60 pods on each node, which it was a huge application, and the requirement was to have as little as possible downtime while the Kubernetes versions get upgraded. Uh, and there were two major problems. So our version of Kubernetes was very outdated. So the latest stable version where we wanted to Kubernetes to get upgraded was almost 3 versions up. And in Kubernetes, you cannot jump the version upgrade. You have to go step by step. So, but a lot of very few people will know this that the control plane has to go step by step, but your node group, those can jump a version upgrade, giving you a lot of time saving. while you do that upgrade if you have like this sort of downgraded version currently, right? So because it's a 3-level down, another fact is Kubernetes only supports 2-level down till node group. So for example, my current version of Kubernetes control plane is 5, then that version can support a node group of version 5, version 4, and version 3. But it will not support a node group of version 2, and it will not support a node group of version 6, right? So we have upgraded our control plane one cluster at a time from version, let's say, 2 to 3, and then 3 to 4. But if we went to the final version which we wanted, we can take the cluster, but then our node groups will be absolute, and those will not be supported by that control plane. So which will result in a disaster for us. So we had to stop there. But then while we were upgrading a node groups, we can easily jump version. Because version 3 of node group can be replaced with version 5 rather than going to 4 and then going to 5. And the way we did it is basically we added an extra set of nodes to the same cluster when the control plane got updated. Uh, then that extra set of node group was with the version 5, for example, right? Then we tainted all the nodes, and because we were using the auto scaling and our each application had multiple nodes, so the one pod gets replaced at a time. So that way, my new node group had a couple of pods for certain applications, even before all the pods from previous applications gets deleted. So that way, my traffic was divided between these two. And at any given time, the application was up and running, either in the older node group or either in the newer node group. So that way, we had almost no downtime for the entire application. And once we have moved to the newer node group, all the pods, we were basically tenting each node and not getting, not letting Kubernetes schedule any new pods on those particular nodes. So that way, one node at a time, we have moved everything, every pods, all the Kubernetes resources to the newer node group with no downtime. And we repeated the same process for going to the, let's say, version 4 to 5. And that way we have moved up 3 versions of our cluster, of all of our node groups and everything. And we had no downtime while doing the activity. This whole process is then, because we are a DevOps engineer and we like to automate stuff, the whole process we then automated. And for the rest of the cluster, it happened with few clicks, obviously few manual clicks, and most of the things were managed by the code that we have written for the automation. So that was a
Okay.
very something that I'm really proud of.
Okay. Seems like a marathon effort, Harshal. Uh, yeah. So how much time it took for this entire process? You mentioned 8 Kubernetes clusters, right?
Yeah.
So how much time it took around?
So I don't know the exact figures. I don't remember the exact figures, but I think the first cluster took us around 4 to 5 hours something to upgrade everything, because we had to do upgrade almost twice. And then onward, after that we spent some time reviewing all the upgrades. If everything is working fine, is there any problem? So we kind of did some testing on the upgraded cluster, so which happens on the lower environment, obviously, right? And then to upgrade everything on higher environments, we use the automation that we have utilized. We have tested it, and then it took around 1 or 2 hours for each cluster. And then because we have already tested the whole thing, we have already seen that it works, and these are the outcomes that we can expect. We did a parallel upgrade for rest of the clusters.
Okay, okay. So you did parallel. So one interesting question I have. So suppose if anything wouldn't have worked, right? So you started with the first cluster, you kind of upgraded it to maybe one level up. So if things would have failed, so what was your rollback strategy or contingency plan so that your application is still up and running?
I'm glad you asked this question. Uh, this is something we, being working with this kind of setup for so long, we have to follow. It's kind of a truth now that if you're doing any change, any such major change, there are steps you have to go through. Basically, take the full backup of the whole cluster. Make sure you have all the deployment scripts. If it's managed through Helm, you have already. but you need to cross check if the Helm and actual state of cluster is not drifted. So you just verify that you take the snapshots of the cluster in case things go wrong. In other scenarios with Kubernetes, things go wrong, you can always roll back. But in cases where you are dealing with the cluster grid, if things go sideways, then you have two options. Either you spin up everything from scratch. Again, there will be a downtime, obviously. There will be a downtime in both the scenarios, actually, if things go sideways. So either you spin up everything from scratch again, or you can spin up things from your backups. So that totally depends on what sort of application you are dealing with. But irrespective of both the things, you should have this basic prerequisite before planning such activity, that you have to have the complete backup, the complete traces, the complete deployment files of each and every resource which is deployed on Kubernetes. So in Node-Group, if I have Ingress, if I have deployment, config maps, everything, I have to make sure that I have all of those deployments files manually backed up on my system as well. And the Helm charts for those are also in sync with the current state. So the steps I have to check. It comes under the prerequisite before we plan such activity. We have to go through all of this. So
Okay,
which
and how many people were involved in this particular exercise?
Around 2 to 3 people.
2 to 3 people. Okay, it seems like you had a lot of fun, many sleepless nights.
Indeed. Yeah, but it is fun.
Okay, yeah. So moving on, Harshal. So I just wanted to understand how your day looks like, maybe as a DevOps engineer. So, uh, like what kind of tasks you do throughout the entire day. So can you run me through your entire day?
Of course, but my day don't look the same every day, uh, because there are times when I'll be building architecture and I'll be convincing the customer why choosing EKS over the ECS is the good choice, or maybe for the same customer on another day I'll be telling him why ECS is better than EKS for us. uh, I'll be doing something like this. There are days where I'll be spending days and nights troubleshooting something critical issues in production, or maybe some things going sideways, right?
Hmm.
And there are days where I'll be kind of going through the whole thing, whole infrastructure, the setup, and looking for things where we can do an upgrade, not trying to find the problems. Usually, we kind of all the DevOps engineer, we don't get suited. We cannot really work with the sprint structure, uh, but we do work with the sprints, though the work cannot be traced properly because DevOps engineers do a lot of ad hoc tasks, right? Something might come up. Somebody's pipeline is failing. So what are they going to do? They are going to come to you. You're going to need to review the whole thing. You're going to see what's going wrong with it. Oh, you have made a mistake here. Just solve it and your pipeline will run. So things like that. So those efforts don't really get counted in the sprint structure for the DevOps engineers, basically. But yeah, we do follow it. We have like weekly or bi-weekly deliverables to maybe upgrade something. So let's say we have a cluster. So the example, same situation where I have a Kubernetes cluster. We don't do that overnight, right? We do a week of planning. We check everything. What could go wrong? How will we solve it? How are we going? If in things go sideways, how are we going to back up? What is our strategy? So we do all sort of testing on the lower environment, and then we move ahead within higher environments. So in day-to-day life, day-to-day is like couple of calls, daily stand-up, couple of calls, solving a lot of issues for other people, and then finding if our pipeline can be improved, if there are flaws in our code, or if there are flaws in our pipeline or infra. Is there a way that somebody could get into our infrastructure? Maybe our security is not that tight. So maybe recommending a security measure, maybe utilizing a completely new third-party service. Maybe uh, we are using the current architecture, but as a demand grows, business grows, the requirements also changes over time, right? Today your priority is the latency and the cost. Tomorrow cost might not be the problem for you. You can get a good funding rounds. In that case, your priority is, I don't want a single second of downtime. Then we work on setting up the complete warm replica for your infrastructure. So things like that. So primarily DevOps engineer does two things. First is resolving issues, and second is looking into architecture and improving it. And there's always a scope for improvement.
Okay. So in short, DevOps engineer job cannot be 9 to 5. Is that what you want to say?
No, not at all.
Okay, okay. So, Harshal, another scenario you have. Suppose you are working for a healthcare customer. Initially, you mentioned about your experience with
Yeah.
healthcare, blockchain, and other domains, right? So, you are working for a healthcare customer, right? For any healthcare customer, IT costs are like cost centers, right? They always want to cut down on IT infrastructure cost, application development cost. Okay.
Yeah.
So consider that we have already developed an entire infrastructure. You can consider it as maybe EKS based or ECS or maybe standalone EC2 based as well.
Mm.
The application is already running. It is up and running. It is on production. But now the customer has mandated to their higher management in cloud that by hook or by crook, you have to cut down on costs at least 30%. Okay. Over the next maybe like 4 to 8 weeks.
Mm.
So how would you approach this kind of a challenge as a cloud/slash DevOps engineer?
Okay. Um, Primarily, when you deal with healthcare and the financial sector customers, there is upmost the highest priority is given to the compliance requirements. They have a lot of compliance. When you're dealing with money and PII, you are dealing with a lot of legal things, right? You need to make sure that data is replicated across multiple regions, it's highly secured, it's retained for almost 5 to 7 years based on the compliance. It is encrypted at rest, at transit. Nobody has unnecessary access for the data. Nobody can download. If things are happening, it should be logged. So, thousands of compliance requirements healthcare and financial sector has. And if it drills down to cutting cost for a particular healthcare setup, basically the architecture for them. So primarily, when it comes to drilling down a cost, we look for two major things. Where are we spending a lot of money? If we have assumed that we are using a same Kubernetes setup, then we check if my application is super critical or it can bear a little bit of downtime. In that case, instead of going for the on-demand instances for the node group, I can go for reserve instances because I know that company, the same application is going to be there for the next 1 or 3 years. I can go for reserve. If it's not even that critical, it's, uh, it can go down and that won't affect any business. In that case, I can go for spot instances for this. If I can reduce the retention of backup, then I can do that. That is something where I can also eliminate some cost. Uh, and combination of using the reserve spot instances, um, reducing the retention for backup, deleting the older stuff, cleaning up, basically the cleaning up the infrastructure that you have. So you might end up piling up a lot of logs and necessary log groups in your CloudWatch, which is just simply costing you money. Reducing that and following practices like that can reduce a cost. Also, in such cases, there are two things will highly help you achieve your end goals. First is AWS's trusted advisor. It kind of displays where you're spending and where you can save some money in terms of your infrastructure spending. And second thing is not just about the cost, but your overall infrastructure's health. You can do AWS's WAR reviews, which is well architected framework review. So based on AWS's best practices and the AWS's best practices pillars, there are certain set of questions that you need to ask yourself, and the answers for these questions will tell you uh, where you can improve your entire architecture, where you can save cost, where you can improve the efficiency of the overall system, right? So combination of all of these things can definitely help to reduce cost, but committing that we will be reducing 30% of the cost without impacting the application or the infra, that's, I don't think, a sensible choice. We can try, and it's a always difficult thing to do without impacting the application, because you can always drill down to half of the cost, but that will end up impacting the system. If my system is not available, then that cost saving is of no use, right? So yeah, it's a combination of all of these things.
Okay. So during our initial conversation, you mentioned you have worked on infrastructure as code, right? So have you ever faced any issues with your infrastructure or maybe any drifts like whatever state you have on your AWS environment or any cloud environment, and what piece of code you have written on Terraform or CloudFormation? So have you faced such issues where there is disconnect between both the things? And if yes, how have you handled it?
Yeah, trust me, Ajit. When I say any IAC, it's a two-edged sword. It works very good, but when the drift happen, it's the nightmare. And we every now and then face the drift because something has been changed. Somebody has made a manual change, which we try to avoid by restricting the access and all. Yes, I do face a lot of I do had face a lot of issues with Terraform being drifted away. So usually the very common reason for this to happen is my infrastructure is managed by Terraform and somebody who has a manual access. Uh, I believe nobody should have a manual access on the cloud. Everybody should only have a read-only access, and anything which gets deployed, gets deleted, gets managed should only happen through IAC, basically Terraform. So that again drills down the number of issues that drift issues that you face overall, right? But if somebody makes a change manually, then you face the drifts. So Terraform will not be able to manage that resource properly because configuration has been changed. Terraform will try to revert it, but in cases where the configuration cannot be reverted, uh, Terraform will simply start throwing error. So the only option that you have is to manually go into a console and sync the Terraform state with an actual resource, or else force Terraform to recreate that resource again so that the drifted resource will be eliminated. And with the help of some advanced Terraform concepts like Terraform state import and Terraform resource import into a state, you can achieve that, or you can simply do a very simple thing that delete that resource and let the Terraform recreate it newly. So you can manage that drifted resource. But it again depends on which and how critical resource has been drifted from the Terraform. And nowadays we have been following a practice in my current project where we don't allow anyone to have manual access. If you want manual access, you have to give a very big business justification why you want it. And even though if you get it, it will be maybe for 1 hour. It is the temporary access that we provide, right? And everything is get logged, what you have changed and everything. So that has drilled down a lot of drifts that usually happens with Terraform in our infrastructure. And now every modification is done by Terraform. And because Terraform is in the pipe, gets applied by pipeline, and pipeline runs via GitLab. So all of my Terraform code, it's version control. So if things go even wrong with this approach, I always know where exact point in time that this particular code works, and this is where it gone wrong. I can always revert back to that code and apply that code and get things sorted out. So it's
Okay.
all the problem of the process, and the solution is also the process.
Okay, so imagine that you are facing a production issue. Your application is facing outage. Okay, and you get a call from your CU that hey Harshal, you need to fix this ASAP. And for that particular thing, you need to do a manual change. Okay, on your AWS infrastructure, and you have a choice whether to do it quickly using your AWS console, or you do the right way in your infrastructure as a code templates or maybe Terraform code. So given the criticality of the situation and the urgency of the situations, so what will you do?
Okay. Uh, I will try to follow the rules because that will keep everything in sync, will not cause a lot of major problems going forward. But if something is super critical and has to be done now, we cannot waste a single minute. Then in that situation, I have to go manual. But the process that what happens after next is important, right? Whatever manual changes that I have to do has to be logged, has to be discussed with the relevant team, and then has to be make sure that it is managed by Terraform going forward. So do we need to do Terraform import for this? Now that issue has been fixed temporarily because of manual activity, how about next week we do a production release, which kind of removes that manual thing, manual configuration, and syncs my change And now that I fixed it, I know what the solution is for a particular problem, right? So with the next release, I fix that problem and it works seamlessly. So it depends. First of all, I will not prefer to do it manually, because when you go manual, anything can go wrong. Second of all, if it has to be done manually, these are the next step, that post deployment on production steps that you need to do. And you need to make sure that if you're using infrastructure as a code, that is in sync with your environment always at any given point.
Okay, sounds good. So consider that you have to create some infrastructure that is not going to be updated quite frequently. Okay, it will be like a one-time job. So okay, so imagine next 5 years it is not going to update it. Will you still use infrastructure as code or do it in console?
Of course, infrastructure as a code. So if two situation, if it's a totally new account, still infrastructure as a code, because I will not remember definitely after 5 years that I have created this resource. If it's an existing account with a lot of resources, nobody will remember that why it is created, who has created it, and what was the purpose, and do we still need it? Why to pay AWS or any cloud provider for the things that we are not even using, right? And after 5 years, nobody will remember it. Managing it through infrastructure as a code will have the Terraform code stored in some of the Git repo. That Git repo will be always be managed by myself or some other team or somebody else, and they will know for exactly why this resource was created, what is the exact configuration that this resource has, and how critical it is. Do we need to replace it, or do we just need to get rid of it? They can do it. Making use of infrastructure as a code with the proper documentation will make your life a lot easier compared to you doing anything manually. I'm highly against doing manual stuff in cloud.
All right, all right. Uh, that was fair enough, but I would have chosen to create it manually, and because as I mentioned that for next 5 years it is not going to get updated. But yeah, it is a choice. There is no right or wrong answer over here. It is definitely a choice. Uh, okay, so we have multiple accounts, like hundreds of AWS accounts. It can be divided into your UAT accounts, production accounts, security accounts, logging. So consider it like a landing zone or a control tower. Okay. So what would be your Terraform directory structure or Terraform folder structure?
Oof, that's a long discussion. Okay, so in cases like this, uh, we are managing everything through Terraform and through my pipelines. So first of all, I'll have a dedicated maybe a repo where I manage my control tower AWS organization related configuration. All the AWS account details will be stored into that. And I have set of different categories of account: logging, security, logging, networking, security, application, maybe backups, and a lot more for maybe costing or something like that, right? I have maybe 10 or 20 set of different groups where there are multiple accounts in it. So I will structure my AWS organization in a such a way that it follows this approach. Okay. Talking about the Terraform's directory structure, you have a variety of choice here. How is your application code is configured or architected? Based on that, you need to decide your Terraform directory structure. So consider a fact you have simply added everything, all of your application code in a single repo, or maybe you created a new repo for each application. In that case, you create for you create one Terraform code. So sorry, I believe all of your account environments, production, UAT, and dev should always be in sync. And whatever happens in dev, if it's verified, will go to UAT, and if it's verified, will go to production as it is without any changes as such, right? It should always be promotional change across your environments. And to make sure that this thing happens and you reduce a number of issues that you might face while doing a promotion or releases on production, you can have a single Terraform code, and you can create multiple workspaces in Terraform, or you can create simply a multiple TFVARS file as per the environment. You can make a use of Terraform's environment. Uh, when you plan a Terraform in such cases, you have a modules directory which basically deals with each service that you are going to utilize. You are going to utilize Kubernetes. So there will be a Kubernetes module created by you based on your configuration, right? And you consume that module onto the main.tf, for example, right? On the root level, that main.tf gets executed and you pass all the TF vars for the dev account, maybe the account number, maybe the user details, maybe the instance size. For dev, if the instance maybe the EC2 will be T2 micro, but for the prod, it can be a very large instance. So those values will be passed in TFRs. Uh, when you do environment promotion, you do that via the CI/CD pipeline. And when you trigger a pipeline for stage or pipeline for UAT, that time the whatever the CI/CD tool that you are using, GitLab or GitHub Action, that will automatically change your environment variable, which is maybe let's say environment, dev, UAT, prod. That changes your environment. That environment variable, change in environment variable will force Terraform to use another TF-var files, which is specifically for that environment. So your value stays the same. Your values get automatically promoted, but your code stays the same, but it gets deployed across multiple environments and hundreds of AWS accounts. And all these details regarding the access and the URLs for this and the account numbers are passed into the values file for each account. Does that make sense?
Yeah, definitely. So yeah, as you rightly mentioned, there are multiple ways where you can implement your directory structure, and it totally depends on what kind of preference, company preference or team preference you have. So it does make sense. Okay, going further with Terraform. So imagine that you are working on a piece of infrastructure like a three-tier architecture, and you have two people working on the same repository or same infrastructure. So how will you make sure that the tasks are segregated amongst both the DevOps engineers and you people do not step onto each other's work?
Okay, so basic Terraform, whoever knows the basic Terraform will always tell you to use the remote state so that the state file is in sync with both the team members. But let's take a bigger example, Ajit. Let's say 20 people are simultaneously working on environment. Maybe you and me are kind of working on the same thing at the same time. So even if our state lock is there, 20 people will log the state at all the time, and I have to wait for my turn to come when the state will get unlocked, and then I can do my Terraform plan and apply, right? And that is not something that I want. I will be losing a lot of engineering hours for those 20 people doing that, right? So what I use a interesting um, uh, what do we call the feature of Terraform. Sorry, I use an interesting feature of Terraform, which is Terraform Workspaces. In the same Terraform structure that we discussed, right? We do a TFRs for each environment. For dev, there will be one TFR, for UAT one TFR, and for prod one TFRs, where the values reside. But for dev, because a lot of people are working at the simultaneously on dev, I use Terraform Workspaces alongside the existing directory structure that I have. So each developer gets their own workspace. And what will workspace do? When you create a workspace, Terraform basically creates another state file for yourself. So you can 24/7 work on it, and it won't disturb any of the developers, right? And based on that workspace, based on that changes, uh, your code get tested, your code gets merged into the UAT, gets deployed to UAT, and then because it gets to UAT, it all the other developers who are working on it has to sync in with it, and then they are also syncing with, and their change also goes well into a UAT whenever they are finished or verified or reviewed, right? In this cases, usually you won't face a merge conflicts because you'll always keep on syncing with the higher branch, maybe the main branch or the master branch, right? And your Terraform code stays stable, and you can simultaneously, like 20 people can simultaneously work on same thing on the same environment. The only problem with this approach is that because 20 people now gonna create 20 different state files for their own changes, it will create a lot of noise in dev environment. It will create a lot of garbage resource in dev environment. So we have to have a strategy in place which kind of removes this excess resource which are modified by each member once their changes are verified. So how we do it? So we create an MR merge request, and we run a pipeline when MR gets created. That pipeline creates a workspace for you, and then you make changes, and once the pipeline is merged, workspace gets closed, and your changes goes to next level. So things like that. So there is another approach. You can create a workspace yourself. You can do it some things, same things, and manually delete it. Or maybe there is another approach where when your changes gets merged, you clean up the state file. You delete everything that your state has created. So I mean, there are approaches based on how much is your requirement and how much complexity you have. But the point being, using Terraform Workspace will solve my issue and let everybody work at the same time.
Okay, so when you talk about Terraform workspaces, is it the cloud workspace or is it the local workspace? Because we have something on the local as well, right? When we install it locally on our laptop, we can do Terraform workspace. And there is also another concept on the cloud or the enterprise version where we can have Terraform workspaces, right? So I hope you're talking about the enterprise or the cloud version of the Terraform workspaces.
Definitely not. We always prefer open source things, the free things to do the job. So the way, because you are using anyway the remote state backend, right? So when you do a Terraform workspace, what Terraform is going to do, let's say your remote is in S3, there you'll see a backend config file in S3, right? Uh, when you do create a workspace and push that workspace, so you have an ability to push the workspace, okay? Just like you push a commit. When you do that, Terraform basically creates a new state file tagged to that workspace. When you do change workspace, because your remote is always backend, it's never stored on local. You do create a local workspace, but your remote is always backend. So the works state file gets created in the backend and it can be managed. So let's say you are working on something, you have created a workspace, you have done half of the job, and then you went on leave. Somebody needs to take care of that, right? So I will simply log in into switch into your workspace, continue the task, get completed, and move on to the next task, something like that. So it always stores on remote state, and it's in the Terraform open source.
All right, yeah. Okay, one last question I have for you, Harshal. So right now you see a lot of AI stuff and MCP stuff, right? Yeah. So what do you think, as DevOps engineers, is our role going to get changed, or maybe we have to keep ourselves abreast with uh, AI tools? So what do you feel that next 6 months will be your plan of action so that you adopt more AI tools, or maybe I just wanted to understand from your end, how is AI going to impact your day-to-day life?
Okay, so there has been a recent study which related to the Gen AI specifically, but now it's booming like anything. That it cannot replace the people who are working, but I mean, you cannot be a doctor. Uh, I mean, you cannot ask the chat GPT to tell me the medicine and it will tell you the right answer, because the way this Gen AI works is based on the prompt that you give it to it. And it always have a limit of how many characters it can process, right? So if you are, if you check things related to the prompt engineering, you'll understand the workings of Gen AI, and the outputs are never 100% reliable. They'll always give a wrong answer. So the AI space is not going to help you if you are not skilled or if you don't know stuff already, right? That will give you a wrong answer and you can create a lot of mess in not just DevOps but any field, right? But if you're already skilled, if you already have a knowledge about certain things, that will going to reduce your time of doing things drastically. The things which used to take you 2 3 days will now simply take you 1 or 2 hours to do, because it will give you everything ready and you need to just tweak things and get it to working, right? In terms of cloud and DevOps, I personally feel that it will coexist. I mean, obviously, the people who will be leveraging the AI tools will um, perform better than the people who are not doing it. And in terms of, so we have seen a drastic change over the past few years, right? It was a cloud, it was DevOps, then we had a DevSecOps, then we had a GitOps. So this trend in the market always keeps on changing, and now going to be an MLOps, or it's going to be an AIOps or something like that. We will have we can see in next 6 months or year, we can see a lot of AI agents getting integrated into the CI/CD pipelines. So, for example, If my pipeline fails, my AI agent can look into logs. My agent can check everything and tell me exactly what's the problem, rather than me going into the logs, checking and spending an hour looking through logs. It can tell me an exact problem and exact solution. I just cross-verified and I applied. Whatever used to took me 2 hours initially, or currently took me 2 hours, will then onwards will take me like 10 or 5 or 10 minutes. Doing this is just an example. So the lot of CI/CD, as we progress, right, we have introduced a GitHub, GitOps, ArgoCD, and everything. It keeps on updating. Things like that will happen. The AI agents will get integrated with CI/CD. They will do certain things. Maybe they will also work with reducing your image size if you are doing containerization. There's a Kubernetes use cases which is also coming up nowadays, where the AI agents will seamlessly manage or check the health checks of your pods, do do a restarts if there is a problem. So the things will automatically start managing itself, and then the number of people that we need in cloud and DevOps space will reduce, but the people that we actually need will be super highly paid with time, because that will be a very niche skill. Very few people will have, and very few people will be experienced in. So that's kind of look at a very bright future ahead for us if we are doing things the right way. But yeah, it's always uncertain. We never know if something new might come up after 6 months. So we are
Right, right.
always optimistic about it. It's always
Yeah.
keep on learning for us.
Correct, correct. I still believe that I am not going to give my LLMs or the MCPs access or write access to my AWS cloud or to my Kubernetes cloud. Okay, so as of now, I'm still comfortable to give read access. Okay, so the LLMs or MCPs can browse through my infrastructure, give suggestions on cost optimizations. But if you ask me if they can terminate my infrastructure or if they can make changes to that my particular infrastructure, I'm still not convinced yet, but yeah, maybe there are interesting times ahead. So
Yeah.
maybe after 6 or 8 months, my perspective can be changed. So I'm open for that.
I
Okay, so
I bet you weren't comfortable giving even a read access a year back to LLM, but now you're ready to do that. So maybe after six,
right,
8 months, you might be comfortable giving the right access as well. Let's hope for the
right,
best.
right. Yeah. Okay, Ashal, thank you. Thank you so much for taking out time for this demo interview on DevOps and cloud. So we had a wonderful discussion around AWS, Kubernetes, Terraform, GitOps, security in general with terms of AWS and DevOps. So I hope you also had a fruitful discussion. And once again, thank you so much.
Thanks, Ajit. Had a wonderful time discussing all of the things. There are always things you can learn and improve, and definitely uh, you and the people can suggest some of the improvements that, on the things that we have discussed, right? And we might find out there are something new tools which can make our life even easier than the way we are doing it. So always looking forward to it. Thank you so much.
Thank
Have a nice
you. Thank you. Thank you, Harshal. Thank you. Thanks for your time. Bye.